The hagfish. Every predator in the ocean breathes by pushing water across exposed gill filaments. That's the one system it can't armor, can't close, or skip. In 2011, baited deep-sea cameras off New Zealand caught 14 attacks on hagfish. Not one attacker finished. A hagfish carries 90 to 200 slime pores, each packed with coiled protein thread and mucus protein that burst and unspool on contact with seawater. Less than half a teaspoon leaves those pores. 40 milligrams of it builds a full liter. The finished cloud runs 20 liters, 5 gallons, in under half a second, faster than a shark finishes closing its mouth. Nothing gets poisoned here. The water just quietly stops being breathable. Most people assume the slime is a sticky glue trap. It isn't sticky at all. It's about 1,000 times more dilute than normal mucus, which is why it floods a whole mouth instead of gumming up one spot. Then it ties its own tail into a knot and slides it forward like a squeegee, because it can suffocate inside its own weapon. Slime is the cheapest weapon in nature, and nothing alive gets a better return on less. No other animal turns half a teaspoon of anything into a 5-gallon weapon before its attacker finishes biting down. The velvet worm. This is a hunter that never touches its prey until the fight is over. No chase, no grappling, no risking a leg. Somewhere along the line, nature looked at a soft-ribbed tube on stubby legs and decided what it needed was 2 glue cannons mounted on its face. They're called oral papillae, and when a cricket wanders close enough, both of them fire in a straight line. Then the tips start whipping side to side, 30 to 60 times a second, painting the target in a scribbled net instead of a single stripe. The slime hits full speed in about 60 milliseconds, and crosses the gap at roughly 16 feet per second. And that whipping isn't muscular. There's no muscle in the body fast enough. A syringe-shaped reservoir plus some clever geometry turns one slow squeeze into a fast squirt, and the elastic tips flutter on their own. The animal aims. Physics does the scribbling. Despite the name, it isn't a worm. Onychophora is its own phylum, closer to spiders and insects than to anything in your garden soil. And the body plan has barely changed in 520 million years. It's been hosing down dinner with the same equipment since before fish had jaws, and it still hasn't needed a second idea. The parrotfish. Reefs don't go quiet after dark. They fill up with things that bite, and a sleeping fish is the softest target available. So every single night, a parrotfish finds a crevice and spends half an hour sealing itself inside a transparent bag of its own snot. Picture going to bed in a clear produce bag you built with your own face. The reason isn't the one everybody repeats. Gnathiid isopods are blood-feeding parasite larvae, and they swarm reef fish overnight. In controlled trials, 94% of uncocooned parrotfish got attacked. Of the ones inside a cocoon, 10%. The envelope blocks a swimming larva while still letting small molecules through, and it scrambles the odor cues those parasites home in on. The common version of this story is wrong, by the way. The idea that the cocoon hides the fish's smell from moray eels traces back to one observation in 1959 that never controlled for anything else and has never been properly tested since. So it isn't hiding from the reef's monsters. It's hiding from the reef's mosquitoes. If slime being an actual weapon is the kind of thing you want more of from me, I'd really appreciate it if you subscribed. Thanks. The sea cucumber. It has no eyes, no shell, no speed, and no brain worth the name. Everything down there is faster than it, and it survives anyway, because when something bothers it, it fires a tangle of sticky white threads out of its own backside. They're called Cuvierian tubules, and they exit through the anus under stress, which is a sentence biology just hands you with a straight face. They leave the body short and thin, then seawater stretches them many times their resting length in seconds, and they turn adhesive the instant they touch anything. An adhesive outer layer over a tough collagen core makes them nearly impossible to pull off. Against slow attackers like crabs and snails, the tubules score between 87 and 100%. So what started inside a soft, fist-sized lump on the sand ends up as a net big enough to pin a crab that was bigger than the mouth trying to eat it. And it isn't vomiting up its guts. It's firing a dedicated defense organ, and a full set regrows in about 5 weeks. Cheapest weapon in nature, and this one comes with a receipt. The crab doesn't get killed, by the way. It just becomes permanently attached to the seafloor, and the ocean handles the rest. The banana slug. On a redwood forest floor, a bright yellow animal moving a few inches a minute should be the easiest meal around. It isn't, and the reason is a chemical, not a poison. Banana slug mucus contains compounds that numb soft tissue on contact with anything wet, which in practice means the inside of a mouth. Garter snakes, raccoons, foxes, and ravens all hunt these things, and it goes badly often enough that raccoons worked out a fix. They roll the slug in dirt first, which binds the mucus and insulates the tongue. A slug with no armor, no speed, and no teeth forced raccoons to invent a technique. The defense holds along the whole Pacific fog belt, Southeast Alaska down to Central California, 1,700 miles of forest floor, where a slow neon slug is somehow not the default snack. Most people believe the slime is poisonous. Turns out it works more like the gel a dentist swabs on before the needle, and it doesn't hurt the predator at all. It just makes the predator's mouth stop filing reports. Nobody has pinned down which compound does it either, which means the most effective numbing agent in the redwoods is still technically unidentified. Slime doesn't have to hurt you. It only has to make you stop wanting whatever you were reaching for. The sea hare. A spiny lobster that gets its claws on a soft-bodied sea slug has already won. There's no shell to work through and nothing to fight back with. It releases 2 secretions at once, and the famous one isn't the one doing the work. Purple ink comes from one gland, a sticky white substance called opaline from another, and both are packed with taurine, which happens to be a powerful feeding stimulant for crustaceans. Which means the cloud doesn't taste like danger to a lobster, it tastes like lunch. Charles Derby's group named it phagomimicry, food mimicry. Lobsters that had just grabbed a sea hare let go, then clawed at open water and dug in the sand, chasing a meal that was never there. Meanwhile, a 15-pound animal, about the length of your forearm, quietly crawls away from a predator that's still chewing seawater. The ink gets all the credit. It's actually the opaline, the boring white stuff, that carries the sensory disruption. The most effective thing you can do to a predator isn't to taste terrible. It's to taste so good, it forgets which direction the food went. The Crucifix Toad. Being attacked by something bigger than you is a problem you can run from. Being attacked by 10,000 things smaller than you while you're asleep underground is not. This frog spends most of its life buried in dried Australian mud, waiting out dry stretches that run for months, surfacing only when heavy rain finally arrives. And while it's down there, the ants find it. Provoked, it exudes something from its back that looks like nothing for a second, then sets into a tacky, elastic hydrogel. It's a pressure-sensitive adhesive that works while wet, which almost no synthetic glue manages. Ants and termites that bite a dormant toad get their mouth parts jammed shut and stay stuck to it. Nature built a frog shaped like an inflated tennis ball, gave it no way to swat anything, then made its skin do the swatting. That reputation as anti-predator armor may hold up against snakes, but the documented job is much smaller. It's aimed at insect jaws. Cheapest weapon in nature, and this one is cheap enough to deploy while unconscious. And ants and termites are this frog's main food, so the ants that came to eat it end up glued to it, carried around for days, and then eaten by it. The boxfish. It's shaped like a cube. It swims like a wind-up toy somebody is operating badly. It has no business surviving on a reef full of things built for speed, and the reason it does is a toxin that's been on record since 1964. Club cells in the skin produce ostracotoxin, released through the mucus layer only when the fish is badly stressed. It foams heavily in water, and it's hemolytic, meaning it ruptures red blood cells in gill tissue. And here's what separates it. It isn't aimed at anything. One boxfish is smaller than your hand. The toxin foams out and spreads through whatever volume of water it's released into. In a confined crevice or a tank, one panicking boxfish can take out every other fish in the space. Aquarium lore says a dying boxfish nukes the tank. Turns out it has to be alive to make and release the toxin, so the dead one is the only one that can't. It's one of very few animals whose weapon doesn't target a predator at all. It targets the water. The best slime weapons aren't the ones that look dangerous. They're the ones nothing on the reef has figured out how to swallow. The slime star. Sea stars eat other sea stars. The morning sun star and the sunflower star both hunt them, and no sea star has ever outrun anything. So this one, a thick, pale, five-armed thing that looks less like an animal and more like a decorative pillow, went a different direction. Stretched above its body is a membrane enclosing a hollow chamber, vented through small pores. When something attacks, muscle contraction forces water out through them and carries an enormous volume of mucus with it. That layer comes off between 6 and 7 centimeters thick. Call it 2.5 inches of gel standing off an animal you could hold in one hand. And 97% of it is seawater the star never had to make. In feeding trials, predator success dropped from over 95% to under 25%. That puffed up look reads as armor or stored fat. It's neither. It's a slime reservoir. Cheapest weapon in nature, and by now the pattern's obvious because almost none of it is actually the animal. And the sunflower star that attacked doesn't get eaten, doesn't get stung, and doesn't get away either. It just stops working for a couple of days. The red-legged salamander. A snake that has already bitten you has, in nearly every case in nature, finished the argument. This is one of the very few animals that wins after the bite. Once a snake has it, the salamander doesn't pull away. It moves toward the snake's head on purpose, loops its tail over it, and smears the whole thing in secretion. The material is about 77% protein by dry weight, and it hardens within seconds in air. Snakes have been recorded unable to open their jaws for up to 48 hours, which is the salamander equivalent of supergluing someone's hands together and walking off. Plethodontidae is the largest salamander family on Earth, over 500 species from Canada into South America, and adhesive defense keeps showing up across that spread in lineages that arrived at it separately. Amphibian skin secretions get filed under toxic slime by default. This one isn't a poison, it's structural glue, and the snake's problem is mechanical. Somewhere along the line, biology looked at a 4-inch animal with no venom and no armor and handed it a tube of epoxy. So for 2 days, that snake is alive, unharmed, and completely unable to open its mouth. The Bootlace Worm. The longest animal ever measured on Earth is a few millimeters wide. No limbs, no shell, no eyes worth mentioning. It lives coiled in tangled brown masses under North Atlantic rocks, and it looks like someone dumped a pot of overcooked noodles into a tide pool. A specimen that washed up at St. Andrews, Scotland in 1864 was measured at around 180 feet. A blue whale runs to about 100, so the record holder is nearly twice the length of a blue whale and about as thick as a shoelace. And the length is the smaller half of the story. Irritated, it releases thick mucus that's toxic to crustaceans, carrying peptides called alpha-nemertides. The most abundant, nemertide alpha-1, binds voltage-gated sodium channels in crustaceans and insects and causes lasting paralysis, while barely registering in vertebrates. Most people believe the blue whale is the longest animal that's ever lived. The measured record belongs to a worm, with the honest caveat that these things stretch, which is why the number still gets argued about. Slime really is the cheapest weapon in nature, cheap enough that we're now trying to farm it. Nemertide alpha-1 is being developed as a biopesticide, because the worm solved this a few 100 million years ago. So the longest animal on Earth isn't a whale, isn't a shark, and isn't a squid. It's a shoelace with a chemistry set. I make one of these every week, so hit subscribe if you want more animals that shouldn't work, but do. Thanks for watching.